All right, so as promised, I am going through part 2 of solving quadratic equations and applications. I'm not covering the applications part because I'm just going to focus on the different solving of quadratic equations. So I'm going to get my sharing started and then we will get going. All right, so this is section 1.4. So yesterday I went through factoring and solving by taking square roots. Now I'm going to go through completing the square and the quadratic formula. So I like to think of completing the square as like doing a magic trick in order to make it factorable and then to make it something that you can square by taking square roots. There's a lot of things about math where we manipulate what we have to make it easier to work with, and that's one of the things we're going to be doing here. So to complete the square, we're basically adding b squared over 2 squared on both sides of the equation. Adding it on both sides of the equation is something that's allowed. We can add the same thing on both sides, and we're doing that to create something that can be factored. We're basically taking something that, let's say, looks like x squared plus 4x, and then we're adding half of that b term squared. So half of 4 is 2 squared, that's 4. And that gives us something that we can factor into a square of a binomial, x plus 2 squared. So we're adding a value to both sides so that we have what we want that we can factor. And so this is all going on the left side here. Oops, my pen. This is all the left side. We're trying to get the left side into something that we can factor. And so that's why we add something to both sides, and then we can factor it. So there's a very strict series of steps here that you want to follow. Step 1, if a is not equal to, so this a that we're talking about, we're looking at standard form. We have ax squared plus bx plus c equals 0. So if a is not equal to 1, which means there's a coefficient in front of your x squared term, you need to divide everything by that coefficient. And then that will get you something that's x squared plus something plus something. Then step 2 is to put your constant, what you have without a variable, to the right side. That way everything that has a variable is on one side, everything that doesn't is on the other side. Then we do the magic trick where you take half of the coefficient of x, square it, and then add that to both sides. And then once you've done that, you factor, and then you take square roots to solve. So we're manipulating this into something that we can then solve. So this whole process, this is where the quadratic formula comes from. Is by following this process, we can actually derive the quadratic formula. So step 4, where it says that we want a perfect square, that's this form. So this is back when we learned factoring. That was p.3. If you have something that's x squared plus 2bx plus b squared, it factors to x plus b, quantity squared. And then that square root property in step 5, that's where you have something squared equals a number. Then when you take the square root, you get plus or minus the value, basically, of the square root. So this is best shown through example, and I'm going to start with something that has no coefficient in front of the x squared. Now, this particular example we can solve by factoring, but I'm going to show you how to use completing the square so that you can see that you can use both methods and you should get the same answer. So this particular problem factors to x minus 3, x plus 1 squared, or squared, not squared, equals 0, which gives you x equals 3 and negative 1. So I'm not going to show the works for solving by factoring. That is in the live session that I did yesterday. But when we go through this completing the square process, we are going to 3 and -1 in the end. So completing the square, first step is to get your constant on the other side. So this 3, I need to get to the right. So I'm going to add 3 to both sides so that I have everything with x on the left. So that gives me x squared minus 2x equals 3. So once you've done that, now you need to do the little trick where you take half of the term with the x, basically what that middle term is, and square it, and then add it to both sides. So I'm taking half of -2. I'm going to just write this off to the side. And then I'm squaring that. So half of -2 is -1. So I'm taking -1 squared, which is 1. So I'm adding 1 to both sides of the equation. And now the left side is something that we can factor. And this factors to x minus 1 squared. So that is a square of a binomial. It's one of the special factors that we talked about in P.3, or P.4 actually, I think was, I always forget which of 3 and 4 was the one about factoring. I think it might have been P.4 actually. But that factors to x minus 1. So when it factors, you're always going to have x plus or minus a value, and whatever that value is always going to be half of the middle term. We are specifically setting up this equation so that it works out that way. So it's always going to work out that way because that's the way we are manipulating the equation. So I factor on the left, and I have x minus 1 squared. And then on the right, 3 plus 1 is 4. So now I am at something that I can take square roots for. And actually, I'm going to make sure that I highlight the work on the left that I'm doing so you can see where these numbers are coming from and you can kind of follow that. So when we have something squared, we can take the square root of both sides. And remember, that's going to give you a plus or minus. So on the left, the square root cancels out the square. I'm left with x minus 1. And then on the right, I have plus or minus the square root of 4, which is 2. Now this is where we have to set up 2 equations. So I said in my video from yesterday that when you have the plus or minus, we can work with some shorthand and write it in one form, but you really want to write it in 2 separate equations because it can lead to some errors otherwise, and when you get to the quadratic formula, you'll have to. Well, you also have to do it with completing the square. So I'm going to have x minus 1 equals 2, and x minus 1 equals -2. So I split up that plus or minus into 2 separate equations, one with the positive version and one with the negative version, and then you solve both of those for x. So I'm going to add 1 to both sides. So I have x equals 3, and we knew that was one of the answers that we got that factoring. And when I add 1 to both sides in the other equation, we get x equals -1, which is the other solution. So this completing the square process gives us the same answers as if you had solved the original equation by factoring. It's a little longer process. The advantage of completing the square is that sometimes things can't be factored. So if you can't factor it, you can't use the factoring method. But completing the square works for every single quadratic. You can always use completing the square. So that's an advantage. You don't have to worry whether it's factorable or not. Are there any questions on this example? Anything I did on there? Any confusion?
I came in, but I'm sure if I watch more of your examples, I think I'll understand it.
Okay. here's a second example. So hopefully the second one will kind of help you out here. Okay, so completing the square, we have to have no coefficient in front of the x squared term. So here we have 4 in front of the x squared term. So we don't want a 4, we need to get rid of it. So we're going to divide everything by 4. So I'm going to divide everything, every single term by 4. So that gives me x squared minus x equals 1/4. Now, second step is to have everything with x on one side and the number on the other side. So we are already at that step, so we don't have to move anything at this point. The next step is now to do the trick where you're doing half the middle term squared. So our coefficient of the x term is 1, so I can write that. I have that minus 1. So I'm going to take half of that minus 1, and I'm going to do this off to this side. So 1/2 the negative 1, and then square it. So 1/2 of negative 1 is negative 1/2 squared. And then when you square a negative, you get a positive, and squaring 1/2 is going to give you 1/4. You're squaring the 1 and squaring the 2. So I'm going to be adding 1/4 to both sides. Now usually I try to leave some space in between so I can write it in directly, but I did not do that this time. So I will just write it. So now on the left I have x squared minus 1x plus 1/4. And then on the right side, 1/4 plus 1/4 gives me 2/4, which is 1/2. Now we've done this specifically because now the left side is something that we can factor. So that minus 1 that was there, we took half of that and squared it. Half of that value is what we're going to use in the factored part. We have this minus 1/2. So when this factors, I get x minus 1/2 squared, and then the right side remains the same. So that 1/2, half of the middle term, is always going to be what's end up in the factored part, every time. So now we have something squared equals a number. Now we can solve using square roots. So this is a method from yesterday. So I'm going to take the square root of both sides. So the square and the square root cancel, so I'm left with x minus 1/2. And then on the right, we're going to get a plus or minus, and then the square root of 1/2. And we're going to take the square root of the top and the square root of the bottom. So the square root of 1 is 1, and square root of 2 is going to be a decimal. So I'm going to rewrite that as 1 over the square root of 2. Now we don't want to have square roots in the bottom of a fraction. That's something that is just not standard across algebra. So we're going to do what's called rationalizing the denominator. And that was something that was covered in P.2. And you do that by multiplying the top and the bottom of that fraction by the denominator, by that square root of 2 over 2. And so that would give me plus or minus. So I still have that plus or minus. And then I have the square root of 2. And then the square root of 2 times the square root of 2 is the square root of 4, which is 2. So it basically cancels out the square roots. And now I have something that I can work with. So now I have x minus 1/2 equals plus or minus the square root of 2 over 2. Now from here, this is where you're going to have two separate equations. I sort of ran out of room here, so I'm going to just kind of move to the left and move to the right. So the first one is x minus 1/2 equals positive square root of 2 over 2. The second one is x minus 1/2 equals negative square root of 2 over 2. And then we solve for x. So for both of these, I'm adding 1/2 to both sides. So on the left, I get x equals 1/2 plus the square root of 2 over 2, which if you wanted to, you can combine those into a single fraction because they have a common denominator. And so you could rewrite it as 1 plus the square root of 2 all over 2. And then on the right side, you're doing the same thing. You're adding 1/2 to both sides. And because they have a common denominator, you can keep them in the same fraction. And so you'd have 1 minus the square root of 2 over 2. And so this is an example of factoring where, or not factoring, solving where you can't factor because things that you factor, you don't get square roots from. You get fractions or whole numbers, but you never get anything that involves square roots. So this is, so far out of all the methods we know, the only way to solve this problem would be by completing the square because factoring doesn't work and it's not in the form to take square roots from the very beginning. So we have to manipulate it so that we can do that. There are questions?
No questions, but I will definitely be reviewing this.
Yes. Now, I would say for completing the square, this is something to definitely have in your notes, but it's not something you're going to need often. So you're not going to ever need this until I can say for sure you'll see it again in pre-calculus and calculus. But for the rest of this course, you're not really going to need this, but I do have to teach it so that those who move on know it for when they need it. So it is shown a little bit in section 3.1, but it's not very, it's not going to be very important. So, okay, so I'm going to move on. If you have to leave the live session and for any reason, go ahead because this is recorded. And you can, take care of what you need to do and then always watch a recording later. So those are the two examples of completing the square, and now I'm going to move into the quadratic formula, which is basically derived by completing the square. And the quadratic formula you can use for any type of solving of a quadratic, just like completing the square works for any type of quadratic. And so you have to have it in the where it's equal to 0, and then you have this specific formula that you have to use. And then that dot there is just a period, so that dot is not part of the formula, but it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So what I recommend doing is each time you do a problem where you're using the quadratic formula, you write down the formula. That way you have it, it will start to be memorized. And this can be used to solve every single quadratic equation. And related to the quadratic formula is a thing called a discriminant. So I talked about the discriminant yesterday when I gave that chart about how to know which method to use to solve. So the discriminant is b squared minus 4ac. That is basically the part that's underneath the square root. So if whatever's underneath the square root is a positive number, that means you can take the square root. And if you can take the square root, that means there's going to be two solutions. And so that also means that if you graphed it, there are two x-intercepts. That is something that you're going to need when we get to, let's see, this is all going to be useful for week 5 when we talk about polynomials. A little bit in week 4, but mostly week 5. So that's going to pop up again in week 5. So if it's a positive number inside the square root, you get 2 solutions. If inside the square root you get 0, then there's only 1 solution because the 2 possible solutions would be the same number. So we saw one of those examples yesterday when we were solving by taking square roots. Inside the square root was 0, and that gave us 1 solution. And then inside the square root, if you get something that's negative, then it has no real solutions, which means it has no x-intercepts. What it means is that it has 2 complex solutions, which is something you'll learn in 1.5, where you deal with imaginary numbers, which are not actually imaginary. It's just they already had something called real numbers, so they said, well, what's the opposite of real? Imaginary. But they're not actually imaginary. They actually exist. They pop up in nature. They're very, very natural. It's really poor naming convention for them. Okay, so I'm going to go through these. I've got 2 examples here. So I have 2 examples of using the quadratic formula. And so I'm going to start by writing the quadratic formula. So it's x equals, and if your variable is not x, say your equation has t, then it would be t equals. So whatever your variable is, that's what you have instead of x. Negative b plus or minus square root of b squared minus 4ac all over 2a. So it's really important to make sure that your square root covers everything it's supposed to, that your fraction bar covers everything it's supposed to, because if you don't, then you would have errors when you're trying to use this. If you are typing up your math, Microsoft Office actually has a shortcut to the formula so that you don't have to type it every time. So when you hit equation, if you hit the drop box, there's a list of common equations, and the quadratic formula is one of them. So that's a shortcut that you can use. So in order to use this, we need to determine what a, b, and c are. And that comes from standard form. Ax squared plus bx plus c equals 0. So the number in front of the x squared is a. So in our example, 2x squared minus x minus 1, a is equal to 2. What's in front of x is b. So since we have a negative, that's going to be negative 1. And then the part without x is c, so c is also negative 1. So your first step is to identify a, b, and c. And this is where most people make a mistake, is either they write the wrong number, or they replace the wrong number in the wrong spot in the quadratic formula. So that's usually where errors occur. The quadratic formula is much more prone to error than factoring. So I always recommend factoring if possible, because you're less likely to make mistakes through factoring than from the quadratic formula. Plus, the quadratic formula is a very lengthy process, as you will see. So I'm going to start by replacing my numbers. So I have x equals negative and then b. So b is negative 1, so I need to have parentheses around it. And plus or minus my square root. Inside the square root, we have b squared. So because b is a negative, I have to put it in parentheses. So that's negative 1 squared minus 4 times a, which is 2, times c, which is negative 1. And then in the denominator, it's 2 times a is 2, so that's going to be 2 times 2. So it's best to try to simplify as much as you can in the same step, just to save yourself some, some work or having to write down lots of things. So I'm highlighting everything that we can do in the same step, because those are all separate terms. So I have x equals. So the first thing I have is negative, negative 1. So those negatives cancel and I have a 1. Then plus or minus, and then I have my square root. So negative 1 squared is a positive 1. So I have a 1 minus, then 4 times 2 is 8, and 8 times negative 1 is negative 8. So that's going to be 1 minus negative 8. And if we're subtracting a negative, that's the same as adding, so you can turn that into 1 plus 8 immediately if you would like. And then the denominator, 2 times 2 is 4. So now, following the order of operations, we need to simplify inside the square root before we do anything else. So I have x equals 1 plus or minus, and then 1 plus 8 is 9. So that's the square root of 9 all over 4. Now we want to actually take the square root of 9. We don't have to worry about the plus or minus because it's already in the formula. So that's going to be 1 plus or minus 3 all over 4. And now this is similar to what we had to do when we're taking square roots, where you have a plus or minus and you have to write into 2 separate equations. So I'm going to separate this out into 2 separate equations. So the first one is x equals 1 plus 3 over 4. The second one is x equals 1 minus 3 over 4. So now, if I take the top one there, 1 plus 3 is 4. So that is 4 over 4, which simplifies to 1. And the bottom one, 1 minus 3 is negative 2. So that is negative 2 over 4, which simplifies to negative 1/2. So we have 2 answers because we got a positive inside the square root, 1 and negative 1/2. Now, inside the square root was something that we could take the square root of and get a whole number. So that was one of the things I indicated yesterday, where if you can take the square root and you got a whole number, that is something you could factor. So this example was also a problem that you could solve by factoring. So this example you can solve either way, you would get the same answer. Any questions? Okay. Now, here's my next example of the quadratic formula. And this one you're going to want a calculator because we've got numbers like 36 and 24 and multiplying and all that kind of stuff is going to be quite large. So I'm going to start once again by writing down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we have our equation, which is in the form ax squared plus bx plus c equals 0. So first step is to identify a, b, and c. So a is the number in front of the squared term, so that is 36. B is the number in front of the x term, so that's 24. And c is the constant, so that's negative 7. So now we're going to replace a, b, and c in our equation with those values. So this x equals, so I have negative b, and b is 24. So I have negative 24 plus or minus. Now I've got my square root. So b squared, that is 24 squared, minus 4 times a, which is 36, and times c, which is negative 7. And then all over 2 times a, which is 36. And now we want to simplify this as much as we can in one step so that you don't have tons of steps to write. So I have my negative 24. There's nothing to do there. And plus or minus my square root. So inside the square root, I can do 24 squared. So my calculator says that's 576. Now the minus 4 times 36 times negative 7. So the minus goes with the 4, that's a negative 4. So I have a negative 4 and a negative 7. We're going to get a positive answer because two negatives cancel to make a positive. And then on my calculator, 4 times 36 times 7. So that's going to come out to a positive 1008. And now in the denominator, I have 2 times 36, which gives us 72. So I've done the squared part, I did the 4ac part, and then I did the 2a part. Now I need to add the values that are inside the square root. It's negative 24 plus or minus. So 576 plus 1008 gives us 1584 over 72. So now we want to take the square root of 1584. When I put that in my calculator, I get a decimal. Because I get a decimal, that means I need to simplify that radical instead of writing the decimal form. So now that is a skill way back from P.2. So 1584 is not obvious to me how that would simplify because it's such a large number, so I would make a factor tree to do that. So I'm going to start with my factor tree. And I'm going to make a guess that 1584 is divisible by 4, and it is. So it gives me 4 times 396. And I know that 4 is 2 times 2, and so those are prime. 396, I believe that is divisible by 9, and that is. So that is 9, and on my calculator it says that's 44. So 9 is 3 times 3. And then 44 is 4 times 11. 11's a prime number. And then 4 is 2 times 2. So if I count how many 2's here, 1, 2, 3, 4 2's, so that's 2 to the 4th. And then I have 2 3's, so that's 3 squared, and then 11. So, simplifying this radical. This is almost going to need a second screen. I have negative 24 plus or minus, and then I'm going to put all of that inside the square root. So I have 2 to the 4th, 3 squared, and 11. And then over 72. I'm going to briefly stop sharing and add a new screen for this because I don't want to smush this in. So I'm going to just stop sharing while I add a second slide there. And then in that slide, we have x equals negative 24, 2 to the 4th, 3 squared, 11 over 72. Okay. And then go back to sharing my screen so that you can see that. Maybe. There it goes. Okay. So that should be matching, yeah, negative 24 plus or minus 2 to the 4th, 3 squared, 11 over 72. Yep, okay. So now we need to simplify that radical. So when you take the square root of something with an even power, you are dividing that power by 2. So the 2 to the 4th, when I take that square root, becomes 2 squared. The 3 squared, when you take the square root, becomes 3. And then I can't take the square root of 11 because the power is odd, so I'm going to just leave that. And this is over 72. Now I need to actually do the 2 squared times 3. So 2 squared is 4. 4 times 3 is 12. So that gives me 12 over 11, or 12 times the square root of 11 over 72. All right. Now we want to write this in 2 separate equations and then simplify as much as possible. And actually, because of the square root of 11, because that's something we can't simplify, what I actually recommend we do is we first split this up into 2 separate fractions, because that will actually save us some time. So if they're both over 72, then I can write them separately over 72. And we can even reduce somewhat. So negative 24 over 72. 72 is divisible by 24. So that would be negative 1/3, because 72 divided by 24 is 3. So that reduces. And then 12 also goes into 72. That should give us 6. So that's plus or minus square root 11 over 6. So now when we have our 2 equations, we have x equals negative 1/3 plus square root 11 over 6, and x equals negative 1/3 minus the square root of 11 over 6. So you can write your answer like that, or you can get a common denominator to combine them, and that would be 6. So if I wanted to get it as a common denominator, I'd have to multiply the first fraction of 1/3 by 2 on the top and the bottom, and that would give me negative 2, and then plus the square root of 11 over 6 to combine those in a common denominator. And then the same thing in the second equation there, I'd have negative 2 minus the square root of 11 over 6. So there are multiple ways to write your answer. You could keep it in the plus or minus form, which we usually do if we have square roots involved. If there are no square roots in your answer at that point, you don't want to keep it in that form. But if there is square roots form, then you can keep it in that form. Then you can keep it there and just stop. Or you can write it by separating the square roots, which is highlighted in orange. Or you can get a common denominator and write the part that's in green. But you don't want to stop at the part where everything was over 72, because there are things that we can reduce. And you don't want to write it as a decimal, because then you are basically you're rounding and it's not the exact answer. The only time you would write it as a decimal is if it's a real world problem, because if it's a real world, then real world answers don't really involve square roots of 11 and weird things like that. We usually are okay with decimals. So if it's a real world situation, it's totally fine to use the decimal approximation of the square root. If it's not a real world situation, not a model, not a word problem, then you want to give the exact answer. Are there any questions? Okay, so that is all I had. I had 2 examples of completing the square and 2 examples of the quadratic formula. And now you have 4 different ways between yesterday's session and today's to solve quadratic equations. And so very rarely are we going to specify a method. You can use whichever method you want. I would recommend that you focus on factoring and then the quadratic formula. because those are the two methods that are going to be useful the most as we go forward. Because we're definitely going to be using the quadratic formula again, and you're definitely going to be factoring again. So those are the two that I would focus on. And if you have any other questions, you are welcome to email me or give me a call. Is there anything maybe not related to what I just did that you might have questions on? All right.